Hi everybody, today I'll be speaking about the cross product, which is a type of product between two vectors. And unlike the other product, which is the dot product, the cross product gives us a vector as a result. So A cross B will give us C as a result. And this vector C has an interesting property because C is perpendicular to both vectors A and B. So it's perpendicular to both A and B. This can be shown here by the first definition of the cross product. So C equals A cross B, and by this first definition we say it is the length of vector A times length of vector B times the sine of theta, the angle between A and B. But this is just a number. This is the length of C. There's something missing here, which is the direction of vector C, and will be given by this guy here, N, with a hat. And this guy is a unit vector. It's a normal vector to A and B. Unit vector perpendicular to A and B. That will be easier if we make a drawing. It's easier to visualize. How come? How can it be? So with the same vectors, we draw them here. These guys belonging to a plane, and we have stated that vector C, the resulting vector, will be perpendicular to these two guys, or to this plane. So C will be in this direction, but does it point upward or down? Where does it point? How do we find out? In order to find out, we'll need to use the right-hand law. Well, not law, but the right hand will help us on this task. First of all, we need to see who comes first. So in this case, it's vector A, because in the cross product, the order does affect the result. So we put our index finger in the direction of vector that comes first, in this case A, and I'm trying to draw the 4 fingers of our hand here, and there is a thumb missing, but that's the thing. So you point these 4 fingers in the direction of first vector, and you try to close your hand, close the 4 fingers towards the vector B, and where your thumb will be located when you try to close them towards the palm of your hand, this will be the direction of the resulting vector. In this case, let me put orange. Okay, in this case, vector C here will be pointing up. So vector C here is pointing upwards. Interesting, huh? In physics, the cross product comes up very often, and so let me write it down here. So in physics, there are many examples. I'll pick one as a property of torque. So torque is defined, so this is torque, and it is defined as the cross product between vector R, direction, position, and force. We can try to use a drawing here just to visualize. So if we have this line here, this lever arm here, and we have vector r here and a force applied here. Okay, this is theta. Using the cross product, we will find torque. I'm representing this in 2 dimension. And where is vector torque? So we have sin r and force here, just representing the same point here. So I try to close, I put my index finger here and I'm looking from above. So I have my finger here and my other 4 fingers are here. So I can just see this is my nail of the index finger pointing in this direction. And when I try to close my 4 fingers towards the palm of my hand, my thumb will be pointing upwards. So this is my thumb, this is the nail. So in this case, in the 2D, R, when you try to come up to F, so because it's R cross F, then torque will be here. So this is the representation torque, because the vector is popping out of the screen. If it would be coming into the screen, this is how we would represent as an arrow. You might have seen this before. So anyway, this is just an example in physics, and there are many others, magnetism and etc. So we will come to the second definition now of cross product, because we don't have much time here left. So the second definition tells us that how do we calculate it? So in this definition, well, first we need to define a coordinate system. Let's say z, x, and y. And we have these 3 unit vectors perpendicular, so I, j, and k. These are the unit vectors. With them, we can calculate c by definition. We calculate c using this determinant here, and then first vector a. So the components of vector a come here, so a1, a2, a3. And an important thing, this cross product is defined only in R3, Okay, and then B here is B1, B2, B3. And I'm not going into calculation of the determinant itself. It's not really the scope of this video, and we're short on time. And if you calculate it, you have C equals, so C equals A2 B3 minus B2 A3, let me put this back, I plus A3 B1 minus A1 3 J plus A1 B2 minus A2 B1 K. All right, so this is the vector C, and we remember that C is perpendicular to A and B, and this is how you calculate the resulting vector using this second definition of the cross product. Okay, thank you for watching.